Welcome to the first of a series of videos on the use of Qnect as a teaching aid for students. These videos were created at the University of Cincinnati with sponsorship by AISC. In this video, we'll be teaching you what is Qnect, how to gain access to Qnect, and the basics of using Qnect. Let's quickly review the learning objectives for this teaching aid. Students will learn to use Qnect in order to perform connection designs. Students will distinguish between the different connection types and implications of design decisions. Students will learn to select design parameters and compare and contrast parameters to understand its implications on connection capacity. This teaching aid is a partnership with the authors of the Unified Design Steel Structures textbook, Lou Geschwinder, Judy Liu, and Charlie Carter. In their textbook, they use a case study building called the Downers Grove Office Building to demonstrate different practical applications of steel design. These videos and the supplemental work associated with these videos will be performed using the Downers Grove building. In coordination with these videos, a hard copy of the instructions for installing and using Qnect with the Downers Grove building is provided on their website. You can access that PDF at this link, steelstuff.com, and from that link, click on Students at the top, and then click on the Quick Guide to the Integrated Design Project in Qnect. If any of the instructions on installing and registering the software changes from what I'll be showing in this video, the Quick Guide will likely be the place where this information is more frequently updated. First, we're going to look at understanding and setting up Qnect. Qnect is a design tool that can be used by fabricators, detailers, estimators, or engineers. It interfaces with Tekla structures to optimize and design cost and time-efficient steel connections. In our case, we'll be using it as an educational tool for students. You'll learn how to use the Qnect software to design your own steel connections in accordance with the AISC 360 provisions. Connections can be designed in seconds, and different parameters can be explored. Your instructor will first need to set up an account for you on Qnect. Once you've been granted your account, you'll need to go to Qnect.com, and then at the top right, there's a sign-in option. You should sign in using the credentials provided to you by your instructor. Once you've created an account and logged in through Qnect, the main page that you'll be led to is your dashboard. In your dashboard, you can either create new jobs or edit existing jobs. This is also where you can download the latest version of Qnect, as it's always being updated. It also provides a Get Started link full of Qnect generated resources to help you better understand how to use their program. Your screen will look a little different than mine because I already have the Downers Grove building model preferences loaded into my account. To do the same, click on New Job and create and submit a project of the same name or any name you would like to use. The project will then appear in the list of jobs below. Click on the project name or the pencil icon to edit the project. Qnect is a cloud-based connection design program which uses Trimble's Tekla as the modeling software. Within this program, you can edit the connection preferences. This website provides the Qnect preferences necessary for the connection designs to be performed for your Tekla model. You can also review connection preferences and view reports for models that have run. It's suggested that you use default parameters for now. More information about the different design parameters within Qnect are discussed in video 3. Before we can use these settings for connection design, you'll need to download Tekla and the Qnect plugin. Please follow along with these instructions in order to successfully download these programs. We'll start by downloading Qnect. From your Qnect dashboard, when signed into your account on Qnect.com, you can download the Qnect program on the left-hand side. It should only take a couple of minutes to download. This provides a plugin for use with Tekla structures. Next, you will need to download Tekla structures by going to campus.tekla.com. Scroll down and then click on Learn More for Students. Next, you will see the option to download Tekla structures. From here, you'll need to follow the instructions to register and activate your free student account through Tekla. Then you will follow instructions to download Tekla structures. The most recent version and the most recent service pack should work with the Downers Grove model. Both the 2020 and 2021 versions were used and are compatible with Qnect and our Downers Grove model. I'll be using the 2020 versions to show you these videos, so you may choose to select that option. Click on the Tekla structures version that you've chosen to download, and then download the program. In order to connect Qnect to Tekla structures, you'll also need to download an additional environment within Tekla. Follow the instructions on the screen and select the appropriate download option, USA. And once you've downloaded the environment, go ahead and open it as shown here. Once you've successfully installed Qnect and Tekla, open up Tekla structures on your computer. You'll need to select the US environment. For your role, select Imperial Engineering, and then select the educational configuration. If you run into issues, check out the quick guide from steelstuff.com, reach out to your instructor, or contact Tekla Structures. Your instructor can always reach out to me as well if there are any technical difficulties. If installed correctly, you'll see a Qnect button within Tekla Structures. If you've installed Tekla 2020, you'll see the Qnect button in the Steel tab along the top. If you've installed Tekla 2021, you'll see Qnect as its own tab, as shown here. Our final step is to open the Downers Grove model in Tekla. Your instructor will give you access to a zipped files folder. Downers Grove Office Building Student Model. You'll need to save this zip folder to your computer, and then you will need to extract the zip files to a folder of the same name by right-clicking and selecting Extract All. Next, open Tekla and navigate to the Open, All Models, and then click Browse to find and select the newly extracted model folder. The model will then be loaded into Tekla. If you don't immediately see the model, go to View and adjust your view options, or toggle off and on the 3D view. This model includes all of the member sizes and geometry for the steel building, as well as design forces needed for the connection designs. We'll talk more about specifics of this building in the next module. Now that you've installed everything necessary for executing this teaching activity, let's talk about how to use Qnect with Tekla through use of the Qnect plugin and buttons 1 and 2. Within Tekla, you'll recall that there's a Qnect button, and within the Steel tab for the 2020 version, and within its own tab for the 2021 version. Here I'm showing you the 2020 version. If you click on that button, you'll see that there are 3 options. 1 is Qnect Export, 2 is Qnect Import, and 3 is Inspect Qnect. Inspect Qnect is for additional changes and troubleshooting. We are going to focus on using buttons 1 and 2. With the Qnect buttons, you're able to export the model data to Qnect and almost immediately import the data back with your engineered connection design. This can happen in a matter of seconds or a few minutes, depending on how many connections you're importing and exporting. Button 1 exports your model data from Tekla to a cloud-based Qnect system. Button 2 then imports the steel connection designs from Qnect into your Tekla model, so that you can see the final designs and all of the connection details. I'll show you how this all works. But if you have at any point issues performing these steps, you can refer to this link for Qnect's own videos on how to manage its functionality in Tekla. Before using the Qnect buttons in Tekla, you want to make sure that you've created your job on Qnect, and we're going to use that job and its design parameters to perform the design. Let me go ahead and show you the functionality of Qnect and Tekla and how they interface together. So if I go into my own dashboard, I've created a job here called Downers, and you'll have already a job created here that you did on your own. If you'd like to make any adjustments to that job, you would click
the pencil button to edit it. If you require to input any additional information, if parameters haven't yet been submitted or selected, it will tell you that is incomplete. And what you would need to do is to go through this information and click submit on all of the different pages, all of these different options. You'll want to go ahead and make sure that you get a check mark and that the work is completed. So essentially, we'll talk about these parameters in another video, but you just want to make sure that right now it's currently just importing all of the defaults, and you would click through this list of types on the left-hand side and make sure you've submitted options for each of the connections so that the connections are able to be designed given whatever are these defaults. You need to give it the criteria so that it can do the design, right? So once we've completed that and we have our model all set and everything is completed, what we want to do is we want to go into the Tekla model. And I'm going to show you how to do just one simple connection, and we're going to look at a beam to girder connection over here. So whenever you want to do a connection design, you can select the entire building if you'd like, or you can select just the members involved with one certain connection. So for the sake of time and just to demonstrate it, I'm going to select the beam and the girder in this beam to girder connection. So you can't just select one member, you will always need to select the two members that together will create the connection. If you do just one, you'll run into an error and it won't be able to handle what you're trying to do. All right, once you've picked them, you want to press the export button. So it's basically taking all of the member sizes, geometry, and forces of the connection, and it's exporting it to Qnect so that the design can be performed. You want to choose the company that you're working for. This should be your university if that's the way that the account was set up in Qnect, and then the job you're working on. So I'm calling this job Downers, and then you want to select a session name. So this is a unique session name, so you'll have to generate a new session name every time you go through a connection, import and export. So you can call it whatever you'd like, something that can identify it. In this case, I'm just going to call it beam to girder connection. It doesn't matter what it is, just make sure you remember what it is so that later you can import it back in. All right, we click submit, and then you'll get a notice that it's being processed. And then you'll get an email. Typically it happens within seconds, especially if it is just for a simple connection like this. If you're doing a whole model, it may take a few minutes. But you'll get an email notifying you that the job is done and whether it completed successfully or not. And if it was successful, when you go to Qnect import, you'll see a similar table here or similar options, and you want to select the one that we just exported. So we want to now import in the data, the information about that connection. So I'm going to click submit to import that information. It completed. And if we look now, we have a connection here. So you can double click on the connection. It will pull up information such as the full list of all of the calculations, different preferences and specifications. So for example, if I click on the calculations, you can go down through and look at all of the calculations involved in this connection. You can look at different reports and drawings to look at the detailing of the connection. We'll talk more about this later. But essentially that is how this works and how you would operate Qnect and install all the programs in order to be able to run these different modules. All right, thank you.